What the is an MCP server? So, AI is a constantly changing field. Um, and one of the problems with working in AI is occasionally you have these things that happen to you where suddenly nothing makes sense. A good example is about 6 months ago, suddenly everyone was talking about MCP servers as if we all knew what they were. And of course, as a long-term computer user and an enthusiast of computer history, I know what an MCP server is. MCP is the master control program. That's the operating system of Burroughs mainframes. And I was very excited that finally, after many years of reading about these things, I was going to get to play with them. But it turns out that's not what MCP is. Perhaps to you, it means this character from Tron, who is the lead bad guy in this beautiful rendering I've done using my PowerPoint drawing skills. Um, he's also called Master Control Program. So obviously it must be Master Control Program, right? That's what the acronym means. But no, what people actually meant was Model Context Protocol. And what is that? Well, imagine that you, as this wonderful bald user, are using a tool like Claude Code or Claude Desktop or OpenWebUI or any of the hundreds of sort of front ends that have sprung up over the past year or so to control things. And you can talk to it. You've got a server down here serving up a model, either VLM or Olama or something like that. And that's fine. You can do your chatting. But what actually, when you want your tooling to take action on your behalf, right? How does that work? And that is what MCP is for. And MCP is a protocol that uses JSON RPC messages over either STDIO or HTTP to talk to a program which does some stuff. Maybe it retrieves information for you, or it does something on a remote machine, it does a database query, whatever. It returns that data to the tooling, which passes it through the LLM, and then back, which interprets it, and then it comes back to you. Okay. So it can run over STDIO. What's that? So STDIO is the standard way that Unix applications do input and output. And if you've not used Unix, Unix is very cool and lets you sort of link together the output of programs into the input of the other. So for example, say you had a bunch of files in a directory, some of them had the word cake in their file name. You could do ls, which would list all the files. You could put it through this pipe command symbol into another command called grep, which searches for cake, and that combination of commands would print out, to standard out, all of the file names that contain cake. Um, in this instance, the tooling can only run these programs directly on the same host, the same computer as the tooling is running on, but it's very secure because it's entirely internal to your machine. You're protected by all the sort of Unix user groups and file permissions and so on. So it's good for development and learning about the process. You can also server over the network, and you can serve your MCP service over HTTP. In this case, it becomes like a standard web service, right? Anyone can access it. So you need to think about security, like authorization and authentication. You need to think about encryption, because you'll have secrets traveling over that. So you need to think about TLS termination. I mean, this is a web service, so all the normal web security things that you have to worry about apply. The good news is that we don't need to write MCP services entirely from scratch. So there's a GitHub org called Model Context Protocol, which I believe is a Linux Foundation project donated by Anthropic, which has implementations for many different languages. And today we use Python for that. The Python SDK works by adding decorators to functions with the right format so that they get exposed by the server with type annotations and so on, so that a model knows how to use them. There are three types of call in the Model Context Protocol. There are resources, which is sort of read-only, right? So they like get some information. There are tools, which take an action. And there are prompts, which do some stuff which allow you to have like predefined prompts inserted into the model output. We'll look at the first two of those today, part of our examples. So as an example, we're not going to code this up, but imagine you already have an existing program which estimates pi through Monte Carlo methods for some number of samples. How much code do you have to do to write a server? Well, not very much, right? You need to obviously import, and you'll see that PowerPoint has nicely capitalized that. Imagine that's lowercase. From Monte Carlo, import the actual function. You want to import an MCP server from the MCP server package. You want to use async IO to wrap it. Then you simply create an MCP server with a name, and And then you add this, you write a function with some type annotations so it knows it takes in an int and returns a float, and then calls estimate pi, and then you decorate it with the MCP tool decorator. And the final thing you want to do is have something to happen when you run this, and so we will run the actual server with the STDIO transport over and wrap it in async IO, right? To add this to Claude code, the CLI, for example, on the command line, we would run Claude MCP add. You can give it a scope, so that can be whether it's for you all the time or for a project or whatever. Tell it it's an STDIO one, give it a name, put in a double dash, and then tell it how to run that server. In this case, we would write the path to the Python interpreter. If you're inside a virtual env, it should be the path to the Python inside the virtual env, because then you'll pick up all the environments, and then the path to the Python program itself. Or you can actually add this to Claude.json, and in the environment where, for example, you have the VS Studio Code Claude Code plugin or extension, and you don't actually have the command line CLI, you have to add this manually to the JSON to the Claude.json file, and there's a syntax for that, right? It's the same information. You give it a name, tell it the type is stdio, tell it where the commands are and what it needs to do. We're not going to do this one though. You can go off and write this yourself if you're interested as a test. It's a good little example. What we are going to do though is do something where we have a much more complicated setup, and the MCP server actually takes some actions for us. So what I've got is deployed in the teaching part of our cluster. I have a small Slurm cluster, which has all the usual stuff. So it's got some compute nodes, it's got some, it's got a management node, it's got a BGFS file system. And I've also put a very simple server.py wrapper, an MCP wrapper, that wraps the commands sinfo, sq, sbatch, and scancel. And added it to Claude code. And so what we're going to do is use that. We'll have a look at that and see what that looks like, and then add it to get it Claude to write a program and submit it as a job, right? One thing you really need to understand with this example, you should not expose this one on the network, because that would allow anyone making HTTP calls to execute code as you, right? Submitting a job is integrally running code. So without quite a lot of work done on authentication and security, you should not put this on the network. So here we are on the login node. It's a Slurm cluster, right? If we run sinfo, we can see we've got a cluster. There's nothing in the queue at the moment. But what I have done is I have here a virtual environment, okay, which just has the MCP CLI in it. And I have a server.py, which does what we said, right? It imports async IO. I've got a wrapper here for the subprocess.run command, and the reason for that is it's just, instead of repeating these things continually, it's nice to have these things already pushed through. Created the MCP server, it's called Slurm. And here I have to find a resource, right? So a resource needs a URL here in our decorator. And what that does is it runs sinfo --JSON. So it will get the output of sinfo will be in JSON. So it's nice and easy for things to parse, and returns that, right? So it's very simple. We've got another resource here to see what's in the queue for the current user. And in the same way, right, it runs sq --JSON. And then we've got the things that actually do things. And I've got two job submission scripts here, because when I started playing with this, I discovered that by default, the model really wants to pipe the job script through sbatch rather than actually running as a file, which is good. All right, it's an interesting way of doing it. So we've got two tools for submitting jobs. There's a tool which assumes that the model will create a job script and pipe it through the tool. And then we've got another which will actually assumes that the model has created a file and then submit it through sbatch, right? You notice in here we're doing things like we're setting the current working directory. That's quite important, because otherwise things go horribly wrong, because the cluster's default working directory will not be, where it's running the sbatch commands won't necessarily where you think it is. We've also got a tool which tells us the how to cancel a job, so it runs scancel. And I've got one which, this should really be a resource now I think I look at it, but it's fine for it to be a tool, which checks the status of a job. And then we've got that command which runs the MCP server. Okay. Now, if we do Claude MCP list, we'll see that I've configured that, and actually it will try connecting to that server. And by connecting to that server, I mean it will actually start up that program and test it. This is a little bit slow because this combination of BGFS on top of multiple Longhorn volumes is not the fastest thing in the world. But as you can see, right, it's running that copy of Python from inside that virtual environment, and that runs that script and it can run it correctly. Okay, so let's use it. So what I'm going to do is create a directory, which we're going to call Py, and then I'm going to start Claude. This is Claude, but it's Claude, if you see here, it's actually hooked up to a Gemma 4 model running internally to UCL in our cluster. So we're not spending any money with Anthropic here. And so what I'm going to say is write a Python program to estimate pi by Monte Carlo methods. It should take a number of samples command. Okay, that should hopefully be enough for it to get it to do the right thing. Write the file. Right, now I'm going to say you have an MCP tool which is connected to a Slurm cluster. Okay. I'm going to tell it something specific, because when I was testing this, one of the things I found with the models is they do tend to like to execute Slurm commands directly, which is quite annoying. Use this and never directly execute Slurm commands. Inspect the cluster and tell its status. So now it's going to try, you can see it's running that cluster info stuff, and it's telling us we've got 4 nodes with 6 gigabytes of RAM and 2 CPUs each, right? This is a tiny cluster, but it's a demonstration cluster. And now what I'm going to tell it to do is a submission script that runs your Python program 10,000 million samples and submit it to the cluster. Okay, and now it sets itself off, written it, and now it's asking for permission to use the MCP command. That's fine. I inherently want it to do that. Okay, it's running this job IHD 60. That one should be a long one, so hopefully it's still running. So if we do SQ, you should see it. We do not. Okay, maybe that was not as fast as I was hoping. So there's an error in the script, right? Let's have a look at that. What did it do wrong? Yeah, so let's get it to fix that. Look at the log file, see that it did not run properly. Fix script. Let's try again. There we go. So it's worked out. It should be running it with Python 3. And there we go, it ran, right, with 10 million samples. Brilliant. So we've got now a conversational interface to an HPC system. Well, a very small model of an HPC system, right? And you can delete jobs with the S-cancel bit and so on. The thing to understand here is we've changed the entire process here from a thing where you need to know a lot about Slurm to a process where you can just tell the AI to submit jobs and debug them on your behalf. Okay, right, move on. Let's do a different demo because I wanted to do a demo of something we could put on the network safely. And so I thought, wouldn't it be nice to have sort of fractals as a service? A while back, I wrote a bunch of Python modules that generate different types of fractals, Julia sets and Mandelbrots. And it turns out MCP services can return images if they're encoded with base 64. So what I've done is I've taken my fractal code and modified some of the image generation stuff because I was using matplotlib to generate stuff, and that doesn't easily allow us to like comfortably set image sizes and things. So I rewrote it to use Pillow to generate PNG, to generate actually in memory rather than generating the file and convert it to base 64, and then have a server.py, and then we'll do it use VS Code's Claude Code extension to generate some fractals, right? So let's do that. So over here, I have a web browser pointing at our unified AI service, which I've shown before, and it's got a VS Code installation inside there, right? So let's look at the code we've written. So I've added some routines that actually write out the image properly. So using pill rather than using matplotlib. So what we want to do is all of our fractal tools produce an array of values, which is how many iterations that took for convergence. We want to normalize that down to 255 levels. We want to write that data out to a file in memory. And we do that by creating a io.bytes.io object and saving to that. It's important to tell it the format here because normally it interprets the format from the file name. And we can't do that because it doesn't have a file name. And then we return that string. Okay, right. So we added some code to change the way we write images, but that, this will very happily, as you can see from this method above, actually just write a PNG image. There's nothing special going on here. On the server side, it's a bit more complicated because we want to return. One of the problems with the MCP is, although it's a protocol, it's not well defined or implemented by anything. And we want to return an image which some tools see as valid output. So actually Claude does, but OpenWebUI does not, right? And we want to return a description so that all the tools know that something has been generated, right? So again, we have these wrapping functions with a decorator, which takes all the information with sensible names, returns something called a call tool result, which we're going to construct. And that will consist of the base 64 image content in the content and a description that says what we've generated. And then I've done the same thing for the Julia sets, right? The only complication being the clever way I wrote the Julia sets. We have to create, we can change both C and N, and we use that to dynamically generate a function. And that allows us to do different orders of Julia set. But the model, the results are the same, right? So we've got this. I configured it in the .json file that I mentioned. And so now we should be able to create a Claude Code session and ask it to generate a Mandelbrot, right? So let's do that. First of all, let's make sure it's configured. And if we do /mcp list, it tells us that we've got one MCP server configured. That's the only one. It's the one I created, right? And so now I'm going to say use the fractal MCP server to generate a Mandelbrot set. We could give it more details. We could give it a range or an area or whatever. Make the image and their X, Y ranges have the same aspect ratio, because by default it seems to not do that. Let's see if we can get a nice image. And there we go. It's pumped out an image. What's happening now is it's parsing the description output. So it will say something nice. There we go. But if we look at the image, look at that. We've got a beautiful Mandelbrot set, right? So that communication is entirely over STDIO, right? It's launched the tool and run it. And it's got that output. Okay, so we can generate Mandelbrot sets through our API, through our MCP call, right? But the next thing to do is to move it online, right? And to show this off, I've got a virtual machine in our private cloud, and it's got Ingress set up so that port 8000 on the VM becomes this URL with a valid certificate and everything, fractals.compo235.condenser.arc.ucl.act.arg. And so the main thing we have to do is change that JSON configuration. Okay, so that instead of having a command and some arguments, it points it at that URL. Noting that we have to add the /MCP on the end, which the documentation doesn't really tell you. But the result of this is if we put that in, we can then directly use that as the MCP server. Okay, so let's do that. So let's bring my terminal over. Here I'm logged into that machine. I've got a virtual environment again. Okay, and we have that server.py. And what I've done is I've changed the line where we ran it with standard I/O to a line that says we're going to run it with streamable HTTP, we're going to run it on all interfaces and port 8000, right? It's a good thing that this is a like relatively safe thing because we'd otherwise you want some authentication, but all this is doing is taking some numbers in and generating an image, right? Absent some inherent flaw in the MCP tools itself, this is relatively okay, right? Now, so let's run that. And now we have the server process running. It's serving on that port. So what I have, what I have here is a different notebook, which is set up differently to the other one in two ways. One, it's actually using the proof of concept LLM hosting condenser, and so I think it's using Qwen as the model. And the second thing it's got in it is that it's actually hooked up to that MCP server, right? So if we now create a session, and say, you actually see it's much quicker because all of that startup cost has gone away, right? Okay. So we can use them in Claude Code, but obviously you can use them in things that use an MCP server generally. So for example, I have OpenWebUI set up, and I've added the MCP server to it here, right? If we look in here, we've got tools fractal, you turn that on. And now I can say in OpenWebUI, can you use a fractal CP to generate Mandelbrot? And here we're going to see some slightly annoying bugginess with OpenWebUI. Specifically, it is very uncomfortable with the way the images are returned. So sometimes it's got an empty result, right? Even though it's actually reserved in the images. So it returns the images, but it thinks it's had an empty result. It's sort of annoying, but it does work. And that's sort of some inherent bugginess in OpenWebUI. So we've generated an MCP server. We've both run things locally and with a web service. And we've had one that makes tool calls to control a Slurm cluster. These are obviously toy examples, but I hope you can see how you might, in your projects, use this to control other things, maybe a database or even control a piece of apparatus that's attached to an AI system.